Hi, today we're going to talk about scatter plots and associations. You've drawn scatter plots for a long time now. What I want to do is first clean up some vocabulary. First of all, what we put on the x-axis is called the explanatory variable. It's the explanatory variable because it tries to kind of help us make a prediction of what the response will be. So X should explain Y. And sometimes we think about it, we sign by the X. Well, the explanatory variable is on the X-axis. Its response is on the Y-axis. With this said, you've seen examples, say, where you look at, let's just take your height versus your weight. And you could make a scatter plot of a bunch of different students' heights versus weights. When we go to describe this association, we're no longer going to use socks because now we have two variables. We're going to use Fuds. The F stands for form. I want to know, does it look more linear or curved? So with this set is, you might have data that you could see fitting with a line, or you might have data that when you look at it seems to have some sort of curve in it. The U stands for unusual. We're looking for unusual points or things that are just striking about the graph that we don't expect. D stands for direction. When we talk about an association, it could be positive in association, like the one I have here, because you can see as X goes up, Y goes up. Or you could have a negative association that you see as the X goes up, the Y would go down. And the last thing here is strength. Somehow we want to talk about, does it look like a really strong association where there's not a lot of noise? And you'll see what I mean in a moment. Or does it look like there's a lot of scatter and it's weaker? So kind of summing it up, form is linear or curved. U stands for unusual. D is direction, positive or negative. And S is strength. So let's go on. Here is a graph of temperature versus the number of chirps per minute that crickets make. And if we Fuds this, we could see right away that the association between the two, if we go for form, is definitely linear. You could see putting a line that would go through most of this data or just even captures the essence of the data. So I would say the association between temp and chirps per minute is linear. Now there's no one unusual, so I'm not going to mention it. Direction, it's going upwards, so I'm going to say positive. And there's very little scatter here, so I'm going to say and strong. Some people might like to add something like, as temp increases, the chirps per minute tends to increase. Okay, so this is an example of a typical Fuds type of question. Okay, let's look at this next one. It's kind of interesting. It looks at presidents over time who have run for re-election. It looks at their approval rating versus the margin of error that they won or lost with. Now, just kind of a quick aside here. If I wanted to show you how to graph this, I can go in my calculator, put all the data in my lists, and then I can add a list, a data and statistics page. And I am going to use let's see, what did I want to use to predict what? Let's see. I'm looking at their approval rating. Is that correct? To predict the margin of error that they won by. Okay, and I believe that looks like our graph that we had over here. Now, we could still say that this is fairly linear. Again, the line doesn't have to go through all of the points. We just have to be able to imagine a line that kind of captures the essence of the association. So I would still say that this is linear. So I would say the association between approval rating and margin of error for victory or defeat is linear. That's my form. My direction is still positive. As the approval rating goes up, the margin of error they win or lose by goes up. And I wouldn't say incredibly strong. I would say moderately strong. Now you might be interested of unusual points. For example, I might consider this guy over here to be unusual. When I checked the data, that was Nixon. So I could make a comment like Nixon had an unusually low margin of error for his win given his approval rating. Okay, you might also want to point out this person, and you can look them up and see who they are. Okay, the next one. This should say 5 vegetables. I love it. Okay, it's 5 vegetables a day and smoking. Now, this is the percent of states where people eat 5 vegetables a day versus the percent who smoke. Now, right away, you should notice that I could probably still call this linear. Okay, because if I go over here, I can imagine drawing a line that kind of captures the essence of this data. But I see someone unusual over there. And I also notice that it's negative, that as the vegetable servings go up, the smoking goes down. And let's see if we could put this together. So let's start our Fuds. We could say the association between the percentage of vegetables, the percentage of people in a state who eat 5 servings of veggies per day versus the percentage who smoke is linear, negative, and what do you think I would call this strength? I'm going to go and weak. There seems to be a lot of kind of clutter and lots of like data that's not tightly clustered. One unusual state had a low percentage of people smoking for the given percentage of those who ate 5 servings of veggies. I looked that state up. That was Utah, if you're curious. So we have form, unusual, direction, and strength. Now, what you haven't seen so far is curved. And the one example I had for curved wasn't coming out too well. And it was kind of interesting. It was something like this. And if I remember correctly, I'm trying to think what was on the axes. Let's see. I'm looking it up right now as we speak. I think it was, give me 1 second. Okay. Fat versus life expectancy. Fat versus life expectancy. And it looked at like 40 different countries. And it was distinctly positive, but it was also distinctly curved. So just something to note that that's something we're going to have to be aware of, that not all data fits nicely into that, hey, it's linear, or hey, it's curved. You could even get data that's linear in one part and curved in another. What's interesting about the fat versus life expectancy example is that it's seeming to say that the more fat they consume in a country, the more the people's lives are going to lengthen, which is kind of ridiculous because you kind of know that if you eat fat, at least in the United States a lot, that can cause heart attacks and other things. So this is what we call, this relationship has the existence of a lurking variable. Let me explain lurking variable to you with another example. If I look at the association between ice cream consumption and manatee deaths, believe it or not, and you know manatees, those cute little animals in the water, it's a very positive association. People think, oh my God, if I eat ice cream, I'm going to kill those manatees. That's just silly. What turns out is that there's a lurking variable. If we think about it as, here's my ice cream, and here's my manatee deaths, there's a lurking variable that affects both of these. Can you think of what it is? What would be something that causes more people to eat ice cream and more manatees to die? Okay, let's think out of the box, and I throw out season. In the summer, more people eat ice cream, and there's more boats out, so there's more manatees that die. In the winter, less people eat ice cream, less boats out, less manatees die. So just because we see an association doesn't mean that one causes the other. So we always have to be careful of what we call lurking variables, like our example here of season. Technically, a lurking variable is a variable that is associated with two other variables in such a way that we might mistaken there to be a causal relationship. But what you have to do is be strong and remember, association does not mean causation. So I ask you, if you go back to the original example of fat versus life expectancy, what do you think the lurking variable is? Well, I'll throw it out there that it's the wealth of the nation. Wealthier nations tend to consume more fat, but they also have to have usually better medical care, which causes longer lives. So again, just because we see an association, I'm getting tongue-tied, doesn't mean that we have causation. Okay, before we wrap this up, what I want to stress to you is that you're going to describe associations in context, but you're going to use the acronym Fuds. Be careful. Not everything falls into a nice category of linear or curved. You're going to see more of that later on. 2, just because you see an association doesn't mean there's a causation. What I'd like you to do in your notebook is sketch what you think each of the following scenarios would look like if you drew its scatter plot. Think about what goes on the x-axis and what goes on the y-axis, in other words, the response variable, and make just a quick sketch. Okay, hope this helps. And before we go, it's drug dosage versus pain relief, calories consumed per day versus weight loss, shoe size versus GPA, age of a car and cost of repairs, and time for a 100-yard dash versus age.